Hello AAG students, I just wanted to put together this video to help you find area and perimeter of triangles and parallelograms with special right triangle rules involved. Okay, so we're going to hop right in here and we have our first example. So I look at the triangle on the left, I have a hypotenuse of 24 feet, and I'm also noticing that I have an isosceles right triangle. Now, how do I know that? Well, I can see I have a pair of equal angles and a 90-degree angle. So once I recognize that I have a 45, 90 right triangle, I'm going to use the shortcuts and rules that we've been using for the last few classes. So in order to go backwards from the hypotenuse back to the leg, I'm going to divide by radical 2. Now, for the purpose of this video, ladies and gentlemen, I'm assuming after 5 or 6 days of dividing by radical 2 and rationalizing the denominator, you guys should be able to come up with 12 radical 2 for each of our equal sides. Alrighty? So, what I'd like to do now is show you, and I really wanted to do that only to focus more on area and perimeter. Alright, so here we go. So for perimeter, I'm going to start off by writing the lengths of the 3 sides. So I'll have 24 plus 12 radical 2 plus 12 radical 2. All right, let me squeeze that in there. Okay, now as I zoom in, all right, I want you to please remember, all right, we can only, combine apples with apples, right? We can only combine our like terms. So in this case, I will end up with a perimeter of 24 plus 24 radical 2 feet. Okay, I get that because I'm just going to combine my coefficients, right? 12 radical 2's plus 12 radical 2's is 24 radical 2's. All right, cool. So there's my perimeter, all right, and we're done with that, right? That's as simplified as it can get. Next, I'm going to move on to area. Now, area, and I've been saying this in class, guys, I need and require to see your 3 steps. Your first step is to always write your area formula. The second step will be to substitute your values. And then the third step will be to write your answer with a label, with the appropriate labels. Okay, so in this case, let's zoom back out for a second. All right, let's go take a look. I'm going to use 12 radical 2 as my base, and I'm going to use 12 radical 2 as my height, right? So let's go ahead, zoom in there, right? 12 radical 2, 12 radical 2. All right, so as I multiply from left to right, I'm gonna multiply 1/2 times 12, and that's gonna give me 6, and then I'm gonna multiply 6 times 12, and that's gonna give me 72. Okay, now I still have to multiply my radical 2's, and guys, again, after 5 or 6 days of saying the same thing, radical 2 times radical 2 is just 2. Yes, it's radical 4, but you should not leave it as radical 4, since the square root of 4 is just 2. So last thing I have to do here is multiply 72 times 2, and that's going to give me an area of 144. Okay, I'm also going to put the appropriate units, which is feet squared. So there is our first example of finding area and perimeter, including special right triangle rules. All right, let's move on to the next one here. So let's find the area and perimeter of this triangle. And as you can see, I have a 30-degree angle. I have a 90-degree angle, excuse me. Therefore, the final or third angle will be 60 degrees. So once I put my special right triangle rules on here, remember, this is the side that's 2x. Short leg, always across from 30, is the side labeled with an x. Long leg, always across from 60, is your x radical 3 side. Okay, so this one should be quick and simple to apply the rule, right? We're going to divide our hypotenuse in half, right? Or divide by 2 to get 12. And then we're going to take our 12 and we're going to multiply it by radical 3 for the long leg. All right, we have now obtained all of our sides. So now let's go ahead and find our perimeter and area. So as I zoom in here, right, let's find our perimeter. I just want to see those side lengths. There we go. So I'm going to write down perimeter equals 24 plus 12 plus 12 radical 3. Okay? Now, again, we can only combine terms that are like, so I'm going to use these whole numbers here. So my final perimeter is going to be 36 plus 12 radical 3 feet. Okay? So I'm going to go ahead and label that there, feet. All right, and that's it, right? Because we cannot combine them together. You can't just squish those terms together just because you want one term. Those are unlike, so we leave them separate. Okay, now let's go to our area. Now I'm going to end up zooming into that space over there, but I'm going to use 12 radical 3 as my base and 12 as my height. You always want the height to be perpendicular to the base. All right, so let's zoom in there. Okay, as usual, I'm going to keep repeating myself. We're going to first write our formula every time, and then we're going to show our substitution, right? So our base was 12 radical 3. Our height was 12. Alrighty, so just like we did in our last example here, I'm going to multiply 1/2 times 12 times 12. If I wanted to, I could do 12 times 12 and get 144 times 1/2 gives us 72 radical 3. Okay, so our final area will be 72 radical 3, and of course, feet squared, units squared. Okay, so let me back out. Here are our first two examples, okay, guys? And if I'm moving too quickly through some of these videos, please don't forget that you could hit pause and or pause throughout the video just so you can see each step of the way. All right, let's keep it going here. Now, this third and final example of a triangle is actually pretty challenging, all right? So what I'd like to do is just quickly analyze my situation here. First and foremost, I notice that we have 45 degrees and 30 degrees. So let's think about that. If I add 45 plus 30, that gives me 75, and then I have to subtract that from 180 to give me the remaining number of degrees. Now that's 105 degrees. We don't have a 30, 45, 105 special right triangle set of rules, right? But what I'm going to do is this, and that 105 stays there, but I'm just going to erase that for a second. In a lot of cases where we have a situation like this, guys, what we can do is drop down your height, right? Draw your perpendicular height. So what I'm going to do is I'm going to assume this is going to be my base, right? So what I'll do is I will draw the height straight down from the tippy top, right, the highest point, perpendicularly, 90 degrees, straight down to the base. Once we do that, guys, we divide this up into 2 triangles, okay? Now, each triangle on its own is a special right triangle, right? As you can notice here, I have the 45, I have the 90, so that's going to leave 45 degrees up here. Also, on the other side, right, on the other right triangle, we had 90 and 30. So that's going to leave, 90 plus 30 is 120, that's going to leave 60 left over, which still makes sense, right? Because the entire angle here is in fact still 105 degrees. In this case, let's think about it. It's kind of simple in the fact that we can just divide out the radical 2, and that leaves us with just 16, right? 16 there and 16 here. Be careful, it's going to come back later on. The 16 that we just found, which is the height of the triangle, is also this side across from 30. So here we go. If my short leg is 16, then that means I'm going to double it to get my hypotenuse, which is 32. And I'm going to multiply it by radical 3 to get the long leg. So that'll be 16 radical 3. We do not use 16 as a part of our perimeter, right? It's on the inside. Perimeter means the total lengths added up on the outside of a figure. Okay, so let me now zoom in a little bit. Let's go ahead and find our perimeter. So, I don't know, maybe I'll start here and kind of go clockwise. Okay, I'm going to need some room here because there's a lot of sides here. So I'm going to have perimeter equals 16 radical 2 plus 32 plus 16 radical 3 plus 16. All right, so we have 4 parts to this perimeter right now, and I want to just kind of focus and zoom in here. I really don't see any other like terms except for the 32 and the 16. Please remember, 16 radical 2 and 16 radical 3 are unlike, right? They need to have the same radicands, right? The number underneath. So, guys, all we're going to do is add up the whole numbers, and our perimeter is actually going to have 3 terms to it, okay? It's going to be 32 plus 16. What's that, 48, right? So it'll be 48 plus 16 radical 2 plus 16 radical 3. Let's go back. Aha, centimeters. Okay, so that's going to be labeled with centimeters. I'm going to find the area of triangle number 1, and then I'm going to add it to triangle number 2. All right, so here we go. So on the left side, triangle number 1, whoops, let me go back, right, has a base and height of 16. All right, so that should be pretty simple. So for triangle 1, okay, let me go ahead and say area equals 1/2 base times height. And we just got done saying they were 16 each, okay? Just to double check, right? Make sure you understand where I'm getting this from. 16, 16. Boom. All right, so let's see. 16 times 16 is 256, right? It's a perfect square. But then we're going to take half of that. So the area of the 45, 45, 90 is 128 centimeters squared. Okay. Now I want to zoom out a little bit. Okay. So that was the area of triangle number 1. Now I'm going to find the area of triangle number 2. So if I take a look over here, I should see that my height is 16, but now my base is 16 radical 3. All right, let me zoom back in here. So the area of my second triangle, the 30, 60, 91, is going to, come on, move over a little bit, is going to have an area of 1/2 times its base. But now, guys, remember, the base was 16 radical 3 now. The height, same as the last, is 16. All right, to finish this up, we have 1/2 times 16 times 16. Well, that's familiar. We just did that in the last example, but don't forget your radical 3 here. Okay, so our final area for the second piece is going to be 128 radical 3 centimeters squared. Finally, we want the area of the entire triangle. So that's going to be all of this space on the inside, right? So the total area will be the area of triangle number 1 plus the area of triangle number 2. Our total area will be 128 plus 128 radical 3. Okay, those are unlike terms because one is rational, the other is irrational, and that's going to be labeled with centimeters squared, and that's our final. Okay, boys and girls, so on these 3 examples, we used our special right triangle rules to find the area and perimeter of 3 triangles.